Hello students, welcome back to Mega Mind Mentor. I am Honey. In this video, we are going to start the new chapter, that is chapter number 2, Polynomials. We will be doing exercise 2.1 and together with it, we are going to look over the concepts of polynomials and its types based on degree of polynomial. So let us get straight into the video. Now the first thing that we are going to see is what are polynomials. So this word polynomial is made up of two different words which are poly and nomial. So the meaning of word poly is many and the word nomial means terms. So polynomial is made up of many terms. Now let us get into the definition of polynomial. So polynomial is nothing but a mathematical expression that is made up of constants and variables, where constants are the numbers and variables are the letter, like from letter A to letter Z. Now these constants and variables are combined by using addition, subtraction, multiplication or and powers. Now let us take the first example, that is 2x plus 3, to understand what polynomials are. So here it combines the number 2 and the letter x by using multiplication and addition sign. Now as you have 2x plus 3, so 2 and x are combined with multiplication sign and this 3 is combined to 2x by using this addition sign. Here the letter x represents any number and here the power of x is 1. So you can see here it is 1 and we don't really write it. Now coming to the second example, which is x square minus 5x plus 6. Now let us see, to combine minus 5, 6 and the letter x, we have used here addition, subtraction, multiplication and powers. The power of x is 2 in the first term and 1 in the second term. Now here you come across something called as terms. And as we started the video, we learned that polynomial means many terms. So what these terms are exactly? So terms are the part of polynomial expressions and they are separated with the help of plus and minus sign. Now let us take the second example, x square minus 5x plus 6. So here you have three terms. This is your first term, this is your second term, and the sixth is your third term, as these are separated by using minus and plus signs. Now let us see what degree of polynomial mean. So by the definition, a polynomial's degree is the highest or the greatest power of a variable in a polynomial expression. Now let us take the given example where you have x raised to the power 5, 2x raised to the power 4, 5x raised to the power 3, 3x raised to the power 2, x and then 6. Now we are looking for the highest power of the variable. So here first of all the variable is x and its highest power is x to the power 5. So 5 is the degree of the polynomial. Now moving ahead, we have something called as coefficient of a term in a polynomial. So let us first read the definition, which says it is the numerical factor of a term containing constants and variable. It means it is a numerical factor of a polynomial term. So for example, we have 4x square y plus 11xy square, and let us say we are asked to find the coefficient of x square. In that case, let me write this term separately that contains x square. So for finding the coefficient of x square, we are going to look for the company of x square. So along with x square, you have 4 and you have y. So its coefficient will be 4y. Let me write some more factors of 4x square y. So 4 can be one of the factors. So it is coefficient of x square y. Likewise, x square can be the factor and its coefficient are 4y. Third, y can be the factor and its coefficient is 4x square. Also, 4x square can be the coefficient. So likewise, you can write number of such pairs. So I hope you understood what coefficient of a term means. Now let us move ahead and discuss about different types of polynomials based upon their degree. So we have the very first type, which is called as constant or zero polynomial. By the name itself, it is very clear that its degree is going to be 0. I can write this 6 as a 6 into x raised to the power 0 because x raised to the power 0 is 1. So it will be 6 into 1 and we are going to get the same number. It means we are not actually changing the number 6 by multiplying it with x raised to the power 0. Now what is degree? Degree is the highest or the greatest power of a variable in a polynomial expression. So here we have the variable x and its highest power is 0. So this kind of polynomial is said to be constant or a zero polynomial. Coming to the second and the important type of polynomial, and this is the term that we are going to even use later in the exercise. So a linear polynomial has its degree equal to 1. You can take this example x plus 2 where x is raised to the power 1 plus 2. So you can see here the highest power of variable x here is 1. So it is a linear polynomial. Now coming to quadratic polynomial. So the degree of this polynomial is 2. Take this example x square plus 5x plus 10. So x is the variable here and we have 1x raised to the power 2 and we have another x raised to the power 1, right here, raised to the power 1. So here the highest power of the variable is 2. So it is a quadratic polynomial. Likewise, we have something called as cubic polynomial. So it will have its degree as 3 and you can see this example. The greatest power of variable x here is 3. Coming to the last type of the polynomial from this list is quartic polynomial where the degree of the polynomial is 4 and you can see here x raised to the power 4 is has the highest power in this entire expression. So I hope you're clear with all of these terms. Now let us move ahead and solve the exercise. Question number 1 says which of the following expressions are polynomials in one variable and which are not? State reason for your answer. Now let us do the first question, that is 4x square minus 3x plus 7. If you look closely, this polynomial has only one variable and that variable is x. Coming to the second one, y square plus 2. Now this expression has only one variable and that variable is just y. Now we have a different case here where we have to first identify whether this given expression is even a polynomial or not. So for that I will rewrite this whole expression as 3 into t to the power 1 by 2 because this root becomes half power of t plus t root 2. Now these kind of expressions are not polynomial because if you see exponent here is not a whole number. So for an expression to be a polynomial, it is very important that the exponent is a whole number. So here this same condition is not getting satisfied. We have the power as half and half is a fractional value. It is not a whole number. It means that this whole expression is not a polynomial, right? Why? The reason for it is because here the exponent is not a whole number. So you can give that as a reason that the exponent is not a whole number, it is a fractional value. So it is not even a polynomial. Coming to question number 4, y plus 2, and can I write this y as y raised to the power minus 1? Yes, right? Now observe carefully. Is this exponent a whole number? No, it is an integer, it is a negative integer. So again, this given expression is not a polynomial and the reason is same, that the exponent is not a whole number. Now coming to the last expression, you have x raised to the power 10 plus y to the power 3 plus t to the power 50. So here you have three different variables, that is x, y and t, and thus it is not the polynomial that has one variable. Now let us do question number 2. So you have to write the coefficient of x square in each term. So from this expression, I am taking out x square separate, and x square actually is x square into 1. So what is coefficient of x here? It will be number 1. That's it. Now let us do the second question. I will write this x square term separate. So x square has a minus sign with it. So it is minus x square, and I will rewrite it as minus 1 into x square. Now what is the coefficient of x square? Yes, it is minus 1. Coming to the third one, you have pi upon 2 x square plus x. So I will write x square term separate, that is pi by 2 x square, and we can clearly see here that the coefficient of x square is pi by 2. Now coming to question number 4, which is little tricky, and let us see how to do it. So for solving this question number 4, I will write root 2x plus 1. As this expression doesn't have x squared term, I will rewrite this expression as root 2x minus 1, and I will produce a term that contains x squared, but I will multiply this term with 0 because 0 into x squared is going to be 0 anyways, and we are not actually changing the question. Now our question was to find the coefficient of x square, and as per this new expression that we created, the coefficient of x square is 0. Question number 3, it says give an example of each of the binomial of degree 35 and a monomial of degree 10. So, binomial is a polynomial that contains two terms, whereas monomial is a type of polynomial that contains only one term. So let us make that binomial whose degree is 35. So I will write here x raised to the power 35, and I will add it with, let's say, 5. So this is a binomial. Let me give you another example. I can write it 10 p35 p raised to the power 35 minus 40. Even this is a binomial. Now coming to the second example, we have to write a monomial with degree 100. So you can take y raised to the power 100, and let us multiply this with 8. So it is 8y raised to the power 100, and it is a monomial. It is one single term that we have. And why it is a binomial? Because here we have two different terms. Likewise, you can make your own expression for a binomial and for the monomial. Coming to question number 4, we have to write the degree of each of the polynomials. What degree of the polynomial mean? It is the highest or the greatest power of the variable in the given expression. So here x is that variable and its highest power is 3. If you see here, here is x raised to the power 1, then x is raised to the power 2, and then you have x raised to the power 3. So the degree of this polynomial is 3. You can just write number 3. Coming to question number 2, y is that variable and highest power of y for this whole expression is 2. You don't have any other y term that has greater power than 2. So for this question, the degree is going to be 2. And now in question number 3, 5t minus root 7. So t is the only variable here and it is raised to the power 1. So its degree is 1. And here 3 is a 0 or a constant polynomial, and we know that 3 can be written as 3 into any variable's power 0, and since the power is 0, its degree is 0, and it is also called as constant or 0 polynomial. Coming to the last question of this exercise, we have to classify the given polynomials as linear, quadratic and cubic. So linear polynomials have the highest degree of the polynomial as 1, quadratic have their highest degree as 2, and cubic have the highest degree as 3. The first question, x raised to the power 2 plus 1. Highest power of x is 2, therefore it is a quadratic polynomial. Coming to question number 2, x raised to the power 1 minus x raised to the power p. So here the highest power of x is 3. So it is a cubic polynomial. Third one, highest power of y is 2. So it is quadratic. In the next one, highest power of x is 1. So it is linear. Question number 5, highest power of t is 1. So it is again linear. Highest power of r is 2. So it is quadratic. And highest power of x is 3, so it is cubic.